Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice in calculating conditional probabilities. Let's get started. First up, we got ice cream. Okay, ice cream, you scream, we all scream for ice cream. And if you're not screaming for ice cream, man, you're no friend of mine, man. Get out of my face. I don't want to know you. So here we have an ice cream shop owner who makes her own ice cream from scratch. And let me tell you something. If there's a local place that's making ice cream from scratch, I'm going to patronize the business just because it's local. But I'm going to patronize it even more if they're making it from scratch. So wanting to know the preference for her flavors, this ice cream shop owner conducted a survey of 750 of her customers. And you can see the results there in the table on the right side of your screen. So the question we're asked is, what is the probability a customer likes chocolate ice cream given that he or she likes vanilla ice cream? Go ahead, pause the video here, see if you can run through the calculation on your own, come back and we'll see how well you did. Okay, let's see how well you did with this. So the probability that a customer likes chocolate ice cream given that he or she likes vanilla, so chocolate given vanilla, is going to be the probability of both of them occurring together at the same time, divided by the probability of the last item, which is the probability to like vanilla. So now that you've set this up, now it's just a matter of calculating each of the different parts. So the probability that someone likes chocolate and vanilla, likes chocolate and likes vanilla, that's 176, which is the part, over the whole, which is 750. You can get that from the problem statement, or you can just add them up. These four numbers, they're going to add up to 750. So there's the probability on the top of our fraction. The probability that the customer likes vanilla is going to be likes vanilla, so it's going to be this whole column right here, 176 plus the 23, give us the 199. That's the part over the whole, which is 750. So now we've got a fraction within a fraction. Note that both of those denominators are the same, so they'll cancel each other out, leaving me with 176 over 199. I divide that on my calculator and I get 0.884. Now, what is the probability a customer likes vanilla ice cream given that he or she likes chocolate ice cream? Again, stop the video, try to work the problem, and then go back and let's see how you did when you come back. Okay, let's see how you work this out. So again, the probability that someone likes vanilla given that he or she likes chocolate. So we're writing it this way. Notice it's reversed, and notice what that does for our calculation. We've got the probability of both of them together. So this is going to be the same here on top, but what's on bottom is very different because this last item here is different. So when we go ahead and calculate our probabilities, we're going to get the same thing on top that we did before, but the bottom is different because we're using now the row of people who like chocolate. So the 176 plus the 543, that gives us a 719. And we're going to punch this out on our calculators and end up getting 0.245. So there's the probability that a customer likes vanilla given that he or she likes chocolate. Are these two variables reasonably close to each other? What say you? Well, I hope you say no, because 88 and 24 are not in the same neighborhood. They're far apart from each other. So we see that the order in which you place these elements matters a great deal. Let's look at an example involving study time. Researchers interested in finding ways to help students earn higher grades conducted a study of how many hours students study during a typical week. The table below shows data from a sample of 700 students. So our first question is, what is the probability that a randomly selected student earned an A, B, or C given that the student studied less than 6 hours per week? Go ahead and pause the video, then come back after you've worked the problem and we'll see how well you did. Okay, let's see how well you did. So the probability that the student earns an A, B, or C given that there was less than 6 hours of study is going to be the probability of both of them together divided by the probability of this last element here. Notice here in the calculation, I'm just including the parts because as we've seen previously, the whole part of our probability keeps getting canceled out. So I'm just going to save myself a step here and just work with the parts. And when I do that, I punch that out on my calculator, I get 0.090. Now, what is the probability that a randomly selected student earned a D or an F, given that the student studied less than 6 hours per week? Again, pause the video, work the problem, then come back and we'll see how well you did. Okay, let's see how well you did with this. So the probability that the selected student earns a D or an F, given that he or she studied less than 6 hours a week, comes out this way, and it's going to end up being 91%. So what do the preceding results suggest? Again, pause the video, take a look at the results, come up with your answer, and then come back and we'll see how you do. Well, I hope you're able to look at these two numbers here and see that one of them is about 10 times the other one. So what that says is that students who don't study, because we're given less than 6 hours per week, okay, that means that you're 10 times more likely to earn a lower grade than you are to earn a higher grade. Let's look at the same problem, but now let's swap things out again with the order. So same problem, but now we're asked what is the probability that a randomly selected student studied more than 6 hours a week, given that the student earned an A, B, or C. Go ahead, pause the video, work the problem, come back, and we'll see how well you did. Okay, let's see how well you did here. So the probability that the student studies more than 6 hours a week, given that he or she earned an A, B, or C, is going to be the probability of both of those elements together divided by the probability of this last element here. Again, I'm working with just the parts. So the part that we earn an A, B, or C and study more than 6 hours per week is 486. And then earning an A, B, or C is going to be this whole row right here. So when I do the math, out comes 0.97. Now, what is the probability that a randomly selected student studied more than 6 hours per week, given that the student earned a D or an F? Again, pause the video, work the problem, come back, we'll see how well you did. Okay, let's check this out. So the probability that a student studies more than 6 hours per week, given that that same student earned a D or an F, is given here. So we've got the probability of both of those elements together divided by the probability of the second element. Again, I'm working with just the parts, and you can see that here. Divide through, and we get 23.6%. What do the preceding results suggest? Again, go ahead and pause the video and come up with your answer, then come back and we'll see how you do. All right, so if you look at the probabilities that are listed here, the higher grade, you're more likely to earn a higher grade when you're studying this greater than 6 hours per week as opposed to the lower grade. So if you're going to earn a higher grade in the course, that's more likely to come from studying more. And well, gee, that just makes sense. So it's good that the results we're getting from the math and the stats actually match what we would call common sense. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.